I'm Colleen Stover with the Center for Space Policy and Strategy, part of the Aerospace Corporation. As you can see, I am here. They do let me out of the studio every once in a while. I'm on location at SATShow 2026. It's being hosted at the Walter Washington Convention Center in Washington, D.C. So I'm very excited about being here. This is the end of day one, and I've already lined up a number of great interviews for you, our audience. We're going to be talking about end-to-end space situational awareness from SSA all the way to action. We're going to be talking to experts about tech transfer, specifically the aerospace DiskSat technology, but that tech transfer going from national laboratories into small businesses and the advantages of that. We're also going to be talking about private industry solutions for maneuverability. And then finally, we're going to be talking about heavy lift rockets. This is a panel lined up with some, quote, heavy hitters from big industry talking about their super launchers. So stick with us, and we're going to go to the first talk now. If you're not watching the show, let me just say, you podcasters are at a disadvantage because you're not seeing all the great pictures and B-roll of all the excitement that's happening here. So if you are listening to the podcast, then please do check out the video as well. All right, thanks for joining. So first of all, please introduce yourself to our audience.
Wonderful, thanks for having me. My name's Kevin Lausten, I'm the CEO of Morpheus Space. We're a space propulsion company, so we build electric propulsion systems that help satellites move in space. We were born in 2018 in Dresden, Germany, where we have a production facility, and we have a footprint here in the US and in Europe, where we support clients for the Western world.
Okay, so thank you. So maneuverability, why is maneuverability important?
Sure, well, we like to talk about space becoming increasingly congested, contested, competitive. It's very active up there. There's over 10,000 satellites in low Earth orbit alone. So being able to maneuver effectively to get out of harm's way is really important. It used to be that the space highway was empty and you could just drive down the highway without putting on the turn signal or speeding up or slowing down to worry about the other operators on the highway. These days, you really have to watch out and pay attention to what your surroundings are and then maneuver around them to avoid a collision. Second, space is contested. It's becoming more and more of a national security imperative. So adversaries are demonstrating the ability to maneuver in space, and we need to be able to do the same thing. And then finally, space is an economic zone where those who can configure their constellation most effectively to respond to ongoings on the ground are going to be the ones that are most successful. So all of those use cases require maneuvering.
Yeah, and so the idea of maneuvering is, you mentioned collision avoidance,
right.
But this road rules and knowing what's around you is more of a kind of space situational awareness, being able to maneuver around it. But it's really, I see maneuverability as really trying to protect the in-orbit environment so that we can continue operating, right? So that there's less debris, fewer collisions. How does the maneuvering feed into sustainability of the environment and other ways?
Sure, well first off, if there were to be a collision in space, that would be catastrophic. That would result in debris scattered around the orbital belt where most satellites operate, and that can be a huge problem. So maneuvering out of harm's way is the first reason. Second, there's an operation called station keeping, where basically you're performing very slight maneuvers on a regular basis to maintain your orbit. So satellites stay in the orbital plane where they're intended to be located.
So as Earth kind of drags them down a little bit, they kind of get pushed up.
A little boost to get back up. Yeah. And then finally, active deorbiting is super important. So when you reach the end of a mission life for a satellite, If there isn't sufficient fuel or propulsion on board, then the satellite just kind of goes dormant and hangs out. And that's a piece of debris, and that's a problem. Having efficient propulsion systems that have fuel available at the end of life is super important, so that you can actively deorbit those satellites and have a controlled re-entry into Earth's orbit and then ultimately running power re-entry.
Right. So tell me, what does Morpheus Space do? What is your technology for maneuvering?
So we build roughly 1U electric propulsion satellites. For those of you who are not familiar with 1U, that's about 10 centimeters on the side. So think of a 10 centimeter cube.
Okay.
And this is a module that just attaches to the side of the satellite. And as long as we can get power and communications from the satellite, we can provide thrust. These propulsion systems can be clustered. So if you need more power, more thrust, you just add another module.
Does that mean to go faster or to go further, or is a larger object?
Any all of the above.
Okay.
Efficiency, increase what's called delta V, which is the amount of force that you're creating on the satellite. If you double the amount of thrust, you double the amount of delta V.
Right.
So you can go faster or you can go further.
Okay.
And then longevity, which ties to the efficiency play. So we've been building these for many years now. We've been on orbit for many years now.
Congratulations.
And it's an exciting time. And the demand is just continuing to grow for propulsion systems as there are bigger and bigger constellations and more satellites, and that factor of congested, contested, competitive space. Those are all driving demand also. So we're excited to be where we are, and we're excited to be ramping up production to support any clients that we want.
So let me ask you, you said as long as you can get power and data?
Power and communications.
Power and communications. So does it have to be, I know that there's a difference between prepared and unprepared surfaces. Can you tell me about the technology that you use and then what kind of propulsion methods you're actually using?
Yeah, so we need a prepared surface. There's a specific port that we use called an RS-422 port, which is industry standard.
RS-422.
It's industry standard. For those of you in the audience who are satellite folks, you'll be familiar with that term.
Okay, great.
And so we use a form of propulsion called field emission electric propulsion. It's a form of electric propulsion, as the name suggests. The fuel type is a metallic alloy. And so what's special about that is everything is contained within the box. When it gets delivered and integrated into the satellite, you don't need an external pressurized fuel tank. You don't need complex piping systems and pressurized systems to move the fuel from the tank to the thruster. It's all captured within that box. And the fuel itself is solid when we deliver it and it gets integrated into the satellite, and it's solid when the satellite is launched, and only when you run a current through it does a small portion of that fuel become melted, and that's when it's activated. So that's when we can create the ion that would create the force vector that ultimately drives the rest.
Interesting.
Yeah.
So why is this type of electric propulsion, and with this particular propellant that you're using, why is that better or different? How is it different than other options?
Yeah, so there are certain advantages, I'd say, and then there are advantages of other technologies as well. The advantage of our technology is it's very easy to integrate. It's very easy to operate, and it's very efficient.
Yeah.
So for those satellite integrators that don't want to worry about the complexity of external pressurized tanks, field emission electric propulsion is a really good way to go. If you have a mission that is going to need to last a long duration, and you're going to be performing many, think hundreds to thousands of very small maneuvers, this technology is really well suited for that kind of use case. So satellite operators are commonly thinking about, how do I get maximum value out of my constellation? Well, you want your constellation to last as long as possible.
Yeah.
So to do that, you need to have an efficient fuel service so that you can perform maneuvers over the duration of the mission and then have fuel available at the end of the mission to actively deorbit things. So if you run out of fuel, party's over,
you're just another piece of junk.
Money stops flowing at that point. You can't actually deliver value to your end customer. And so oftentimes the limiting factor in mission duration is availability of fuel. So having an efficient propulsion system like Morpheus's go-to propulsion system is a really useful way to ensure that you drive maximum value out of your cost addition.
Nice. So what's on the horizon for maneuverability, do you think, in terms of this decisions that the government can make now for making sure that we do keep debris and collision, all of these things lower down? What do you think?
So a couple things that I think are going to happen. We're seeing more and more regulation around satellites needing to have propulsion systems on board to perform active deorbiting. We need to keep doing that. Western allied nations need to enforce these regulatory policies and focus on ensuring that everybody's a safe operator in space. That's one point. Second, more of a prediction. As space becomes more complicated, the mix of propulsion technologies that will be required is really important. So electric propulsion is really good for certain things. Chemical propulsion is really good for certain things. Nuclear propulsion is really good for certain things. Having satellites that blend these technologies together and have what are called hybrid systems, where you've got EQ and CP operating together, I think that will become increasingly important as the mix of maneuvers and use cases for the space continues to expand out.
Yeah. I think there's definitely strength in having choices.
That's right. That's right. And having flexibility once you're on orbit. Like, the problems of today don't necessarily represent the problems of tomorrow, but you want to be prepared for the problems of tomorrow, and having those different technologies on board allow you to be nimble once you're already on space. Because once you're up there, you can't really make changes.
Yeah, and human activity is only going to increase.
That's right.
Thank you very much for joining the Space Policy Show today.
Thank you.
Hello, I'm Debra Emmons. I'm the Chief Technology Officer and Vice President at the Aerospace Corporation, and I'm joined here with Rama.
Hi everyone, my name is Rama Afullo. I'm the founder and CEO of Satlyt, and it's a pleasure to be here.
Great. Well, I'm glad to be here too. And we're here at the Satellite Show, here talking about DiskSat. Very exciting. So let me give you a little bit of background about DiskSat. So DiskSat was a concept that some of our engineers had come up with. It was sponsored by the Space Force and NASA. It started as a concept, and of course we've developed it, and we had launches of DiskSat in December, and now we're doing the commercial transfer. And so for everybody to know, what we've done is we've taken the CubeSat, the small form factor, and created an entirely new form factor. So it's a 1 meter disk, a couple centimeters in thickness, and essentially it enables so much more power for its size. 200 watts compared to 20 or 30 watts for a regular, small CubeSat. And to me, I think this is so exciting because it basically can revolutionize and just change the way we think about small satellites.
Yes.
So, since you're one of the first ones out of the gate there with the commercial license, why don't you tell us about how you're thinking about it?
Yeah, sure. So just to set the table, at Satlyt, we turn satellites into nodes in a virtual AI data center in space. I've been working on this for the last couple of years, and we've partnered quite heavily with NASA, the Glenn Research Center, with the NASA Ames, and 3 other NASA centers as well. And I realized after we started talking to your team that I'd actually seen a DiskSat before. I'd seen a DiskSat at a couple of different events, and I'd always been interested, like, what is this form factor? Why does it look like that? I haven't seen a satellite that quite looks like this. It's not just a box, right? So that was always interesting for us. And for us, given our mission, which is to sort of be the control plane in space and to make the space industry have a standard language that they cross-communicate, we want to work on as many different form factors as possible. We want to work with the best partners. And NASA had nothing but great things to say about the Aerospace Corporation. And for us, just given our history, having met with a few different folks with past leadership at the Aerospace Corp, we're always open to interoperability, always open to testing and trying out new things. And I think that's a testament to the DiskSat mission. So when we got the opportunity to jump in and be a licensee and start to dive a little bit deeper into the conversation and meet with your teams who had nothing but positivity and a super great outlook on the ways we can work together. I think that led us to being very comfortable with joining this mission, with starting to understand how the DiskSat operates. And we're very early on in that journey, but we're about to start working on some test beds as well, sometime in the near future, and then potentially start to cross-collaborate on ways that we could work with DiskSat in orbit.
Well, that's exciting, and I'm very, it's certainly a really interesting application here with the AI compute and doing the data centers in space.
Yeah.
I think one of the things that we're most excited about is, this DiskSat, the ultimate measure here of success here is how much we can see this tech transfer. It's not enough to just come up with the concept. And again, we've had successful operations going on right now with formation flying and trying to verify sort of maneuverability and operating in very low Earth orbit, like down to 300 kilometers or 1,000 kilometers. But the ultimate success is really going to be in these commercial licensings and really seeing, the commercial players being able to take it and really do some new novel things with it, both whether it's putting payloads on it or in, building them at scale, or in, like you're thinking about, changing the infrastructure in, say, with data centers. So the ultimate, I think, is all about that tech transfer.
Yep.
I think we have 40 different companies that are interested. We're really working with DiskSat to be a non-exclusive license.
Of course.
But I think what's really exciting here is what you're thinking about with the AI compute applications.
Yeah, I mean, for us, it's super interesting already. It's always an extra high to be able to say we were one of the first, right? And helping to sort of set a trend, I think, in a positive direction. And what people are craving in the space industry is something different, something new, something that represents real innovation, not just innovation masked in another box. Right, so I think DiskSat represents that in a myriad of ways. And when we look at what the craze is now with folks doing sort of the physical, vertically integrated data centers in space, power budgets are going to be a massive factor, right? So anything you can do to reduce that is super, super interesting. And we're seeing that with DiskSat as well. And of course, also the space savings, right? And the number that you can deploy in one go. I mean, that's a game changer, right? For a lot of different people. We're partnered with a bunch of different research institutions. And for them, having a form factor that like reduces costs, increases the power productivity in general is something that's super, super useful, right? So people have been actually knocking on our doors ever since you put out that press release, right? And that's been exciting for us also.
Right, and you're thinking about having someone else build them at scale,
yes.
Right? Yes,
exactly.
Right, yes, and I think that's an interesting way of really all the facets of how DiskSat will be an enabler here.
Yep.
But I think ultimately the measure will be in tech transfer,
yes.
But across the board, whether it and we'll be working, I think, with the different partners here, both from the subject matter expertise as well as just the ways the thinking about the DiskSat. And as you said, it's also really conducive because we launched 4 of them and all kind of sitting in a fairing. And that was, really interesting there.
Yeah. I mean, I love to see the launch. I was very excited because we're in the middle of signing this license, and the launch came out. I said, okay, great. It's even more real now, right? So kudos to you and kudos to the team. We love working with the Aerospace Corp. And thank you so much, Debra.
And I'm looking forward to really successful stuff. And what's your timeline?
Our current timelines have actually just scaled out significantly. We got flight heritage this morning, which is breaking news for us as well.
Oh,
we'll get even more flight heritage on Sunday. And these are 2 different ways that we're doing this. This morning we uplinked our software directly into a satellite already in orbit. On the weekend, we have preloaded our software onto a satellite that will be going up in space to optimize their solutions and to eventually have them as part of this interoperable space node solution that we're putting together. So for DiskSat, we're in the initial parts of sort of like testing things out on the test beds. We're starting to talk to those teams. And eventually we'll get to the point where we're comfortable enough with the way it works. It shouldn't take us too long, all right? And then start to figure out which customers want to partner up with launching out some DiskSats as well.
Great.
Yes.
Well, that should be very exciting. And you already mentioned you're working heavily now with NASA.
Yes. We were one of the 47 companies that NASA awarded an STTR grant last year. And that's with the autonomous quality of service and edge AI really being deployed into space, finding a layer for interoperability across homogeneous and heterogeneous space systems, in general. So that's been very exciting for us. So folks like NASA, the Aerospace Corp, the people who look at the world as something that, look at space as a unifier, right, rather than a divider, like across the board. For us, those are always the people we want to work with as much as possible.
Very exciting. Looking forward to seeing the DiskSat in all of these applications.
Yes, most definitely. Thank you so much.
Thank you.
Thank you, Debra. Appreciate it.
I'm here with our guest, Robin. Can you introduce yourself?
Absolutely. Hi, I'm Robin Dickey, and I am the Director of Policy and Government Affairs at Slingshot Aerospace.
Okay, Slingshot Aerospace. What does that company do?
It's a great question. We are a space operations, intelligence, and autonomy company. So basically, we support the satellite operators in their decision cycle all the way from sensing and fusing data to deciding and acting in space.
Interesting. All right, so every story has a beginning. You start with sensing and then you go all the way to acting.
Mm-hmm.
Tell me about the sensing part.
So Slingshot has a global network of optical sensors spread around the world and looking up at space. We have a really interesting mix of staring arrays. So you'll look at a huge chunk of the sky and see anything that passes in front of the sensor. We mix that with cued sensors that will follow, say, oh, this looks interesting. We're going to follow that very specifically. Mm-hmm. But then we fuse our data from our network with data from all sorts of other sources, companies, public shared data, not just from sensors, but we have contextual data. So basically information on who's launching what's in those satellites, insurance filings, going all the way back to Sputnik.
Wow.
So we can combine all of that data, fuse it together, and we've created what we call our digital space twin. So near real-time 3D imaging of what is happening in space that you can use to help understand if there's anomalies, if odd things are happening, if you're at risk of a conjunction and maybe running the risk of running into someone else, then what can you do to keep yourself safe, operate, and move forward and make decisions?
Interesting. So who are your customers usually? Do you have domestic customers, international customers, government, private entities?
All of the above, really.
Okay.
We work with the U.S. government, we work internationally, we support the Department of Commerce in their TRACS program for space traffic coordination. So we try to help wherever we can.
What's that thread in terms of maintaining the space environment and what you guys do?
So one thing that we've really realized as a company is that awareness, space situational awareness, is just the beginning. So you may know what's happening in space, you may have a sense of the number of objects, but in order to stay safe, to keep your operations going in the future, you need decision-grade intelligence. You need to know, for example, we have AI tools that help analyze all of this data and turn it into something actionable. We have a tool called Agatha, which is anomaly detection. So say a group of satellites has been launched, you're told what the purpose of those satellites may be, but our AI might notice, hey, 3 of these satellites have started kind of behaving unusually. And either that is potentially a threat that you may be concerned of, or it could be that there's a safety risk, someone's lost control. And so being able to not just see what is happening now, but predict based off of past and present information, what may happen in the future and what should we do about it.
Yeah, I love how all of these all-knowing, omnipotent, knowledge bases are named after females. Agatha.
Yes, there we go. I love that.
Okay, so in terms of the SSA, this being able to kind of see where things are going or happening right now, but then also to be able to predict it, how do you think that might grow into another business case? Like thinking about maybe a little bit of the future in terms of all of your sensors are on the ground looking up, which normally people think of space sensors as things looking down.
Absolutely.
So what about the future space economy or the cislunar environment? How do you envision what you guys do to be able to translate into that kind of future?
Absolutely. It's really a challenging question looking forward. I think our perspective, especially on the sensor side, is there's so many different types of sensors, different locations where you could put a sensor, different levels of orbits, and all contribute something really valuable to the piece of the entire puzzle of what's happening in space. And so I think we are really focused on what do you do with that fusion, that integration? How do you get a common source of truth, especially because every sensor's got a bias, so you need to understand how those sensors are calibrated in order to, if you're getting two different companies, for example, giving you two different messages on whether or not you're having a conjunction, how do you actually decide what to do based on those conflicting messages? These levels of artificial intelligence, machine learning, data fusion, and again, combining sensor data with contextual data, all of these are necessary to try to find that nugget of truth within these massive amounts of data that we're seeing every day.
Okay, so you are government relations, director of government
Policy and Government Affairs.
Policy and Government Affairs, I'm sorry. So in terms of either Slingshot or companies like Slingshot that are those kind of data fusing, do you have any ideas about maybe what kind of government policies could enhance your ability to bring that kind of important data to customers now and future customers?
Well, so in my recent experience, because I was a Hill staffer not too long ago, we worked a lot on defense acquisition reform. And there's a lot of lessons in that I think are applicable not just for defense, but for how public-private partnerships work across the board. Everyone's talking about how we need to go faster in integrating commercial technologies. There's so many amazing little nuggets of technology that companies have that we're trying to get into the hands of the operators that need them. And so in some cases, the operators are warfighters on the defense side, but also operators of just other commercial satellites. And so what I've seen in a lot of this policy is that we've had a lot of great top-down direction, especially in the last year, saying we need to work together, we need to go faster, we need to be willing to take risk when risk is smart. The real challenge now is taking that top-down direction and trickling it down into contracting officers, into the culture of public-private partnerships. And so in some cases, we have a lot of the building blocks. It's just implementation and integration on that deep cultural level that I think is going to be the next step in how we all work together going forward.
Excellent answer. And of course, everybody, all of these stakeholders have stake in the outcome. And so some of the, maybe some of the tension might be kind of ownership, if you will, of within the government of who is going to control what, and being able to give up your piece of the pie a little bit in order for a greater good.
Yeah, it's a big challenge. I don't know that I have the solution to it.
Well, we're here at the SATShow 2026 in order to talk about these challenges and find ways forward.
Absolutely.
So thank you very much for joining. I will add that Robin is a former CSPSer.
I am, an alum.
That's right. So we're really happy for you at your new position with Slingshot, and thank you for being here today.
It's been a real pleasure. Thanks, Colleen.
Bye.
Is going to be a bit of a speed run.
Right now, the space economy is extremely complicated. Hello, I'm Karen Jones with the Center for Space Policy and Strategy, and I'm here with David Hartshorn. David, could you introduce yourself?
Certainly, Karen. I have been in the satellite industry almost 40 years now, based in London, Hong Kong, Singapore, Silicon Valley, Washington, D.C., and now I'm in the sunny state of South Carolina. I've been focused on satellite communications because it is dynamic and touches people's lives in ways that I have found gratifying, and that has never been more true than it is right now, and I think we'll probably be talking about that in a few seconds.
I think so. In fact, speaking of dynamic, your panel today, Battle of the Big Rockets, was very lively. you covered quite a bit of ground there.
Yes. Fortunately, no fights actually broke out. It was fairly collegial, but we did have the main contenders in the launch sector here. We had SpaceX. Seated beside them was Arianespace, Mitsubishi Heavy Industries, of course, Blue Origin, ULA.
Yep.
Fantastic lineup of companies.
It was a great discussion, and what struck me was really there were quite a few buzzwords, and there was a really agreement as to what the key trends were in the business and the key challenges as well.
That's absolutely correct. And the very first person to introduce themselves and their company and their perspective on the topic, the word that came out first was cadence.
Yep, I heard that many times.
And we heard it again and again from literally every one of the speakers. And I think it has everything to say about what everyone is asking right now.
Yeah, which is the market. What's going to drive the market for super heavy lift?
What's going to drive that market? Yes. And how are they going to satisfy that demand? Can they pull it off? We're talking constellations that are sized at 1 million satellites,
right.
100,000 satellites, 200,000 satellites. It's at a scale that we've never even talked about.
Yeah.
So how can they realistically do this? And that became a running theme throughout the discussion.
Right. And also another running theme was the competition. And that term that comes up is sovereignty.
That's right. We currently find ourselves in a very geopolitically dynamic environment. And it's no less true for the big providers of launch services. So what happens when you have someone who wants a satellite launched out of a country that maybe is a belligerent to another country who also has an alternative launch option? So these sorts of questions are in play right now around the world. There are open hostilities, as we all know from the headlines, and that has a lot to say about how launch providers are approaching their potential customers.
Right. And as far as the customers, that's another interesting theme, which is what is going to drive the market? Is it orbital data centers? Is it mega constellations supporting connectivity? And there was some discussion around that as well, and how to arrange and prep these rockets to manage that kind of demand.
Yeah, we asked each of the panelists to draw a pie chart for us in the air of the ratio of commercial to defense type customers that they're currently seeing today, and whether or not that is shifting in any way. And I think we heard that there's a consensus opinion that they're both going gangbusters, each for their own reasons.
Yeah.
And just a quick word on that. We've already talked about the geopolitical tensions in the world. That's driving defense budgets in new ways. But on the commercial side, there's just as dramatic a story playing out there where you have decades of attempts to bridge the digital divide that have gradually made progress, which is now being seen exponentially at a level never before seen. And that type of expanded access is what is driving demand ultimately for these huge constellations.
Right.
The world has had a taste and they like it.
Yeah. And what's going to be interesting is the economics and what are we going to reach as far as dollars per kilogram for upmass? Do you think these big rockets, these super heavy lift launch vehicles will be the key to achieving really low launch costs?
Well, volume is king.
Yeah.
So in this case, the answer I would say, and I'm not a rocket analyst, but I would say the answer has to be maybe.
Yeah.
It's going to depend on a whole lot of things. The success of each of the launch companies in getting their systems off the ground repeatedly and successfully. So that then will contribute to the extent to which there is competition, which then either does or does not put downward price pressure on launch costs.
And that would include reusability as well. And
absolutely.
Of course, lower launch.
And we asked that question.
Yes.
Is there innovation in play right now that will enable your company, to go to that next level that is going to be required in all likelihood to meet this crazy level of new demand?
Right.
And the answer was, not surprisingly, yes.
Right.
And we heard a wide range of things that are being done by all of these big launch providers.
Right, right. And to achieve these lower launch costs, of course, reusability should probably be part of that. But it also helps from a sustainability perspective long term. And I know the panel was wrapping up. You had a full house of speakers there, but could you speak a little bit more to sustainability and the concerns?
Yes, tragic story that. I had actually written that down on my list of topics to address. It was on a short list, and we got carried away on supply and demand and pricing implications and policy and other topics, and before you knew it, the 45 minutes was up. We did not talk about space sustainability. We could have run an entire session. You know, we could have run an entire conference on space sustainability, and the stakes have never been anywhere near as high as they are right now. So if I had it to do over again, I would have tried to find a way to squeeze in the question, okay, unprecedented volume of mass that has to be lifted into various orbits around our planet in a fairly short period of time. How are you going to manage, how are you going to prevent or at least mitigate the introduction of additional debris into any of those Earth orbits?
Yeah.
What are you doing? How does that factor into your engineering, your planning? Are there incentives that your organization has other than self-preservation? Who's involved in that process? Is there a supply chain dynamic that has to be leveraged that is currently not? How do governments feed into that? What does this have to say about policy? There are so many questions about this, and maybe next time we'll get to it.
Yeah, I think you should talk to the organizers for next year's session. I think that'd be a very good topic, and it's one that is still very relevant right now, especially when we think about the upper stratosphere and the amount of debris coming down and burning up. What does that mean for our environment?
That's right, and I can tell you firsthand in discussions that we've been having about seemingly unrelated opportunities like market access. In the rooms where these government ministries are seated, together with local private sector, there is active debate underway around the world in developing countries as well as the developed about whether or not markets should be thrown open or eased open even for increased access by LEO or any satellite service provider. And one of the objections that is being voiced is, well, what about the introduction of pollution into Earth's atmosphere through re-entry? So the industry needs to get that message out about what they're doing to address that concern.
And conversely, a Superheavy lift can take more up mass. So in one way, it's efficient on the way up, introducing mass into orbit.
Yep, well said.
Well, thank you for your time. I think that's a wrap, and hope to see you at Satlyt 2027 next year.
Well, thank you, Karen, and thanks to Aerospace Corporation for helping to make that session possible here at Satlyt 2026.
Thank you.
Well, thank you everyone for joining the show today. We do hope that you enjoyed the variety of guests we had on, many of them from small commercial companies that are really trying to integrate themselves into government programs, just like government says they want to do. So, Space Policy Show was there, really leaning into it, and we appreciate the invitation to this year's SATShow 2026. Again, if you are just listening to the podcast, it's worth a look at the YouTube video. You never know, in the background you might actually see somebody that you recognize. Thank you to Matthew Ricola, our technical director. All of the center's deeper research is at csps.aerospace.org, and of course, all of our shows are available there as well. Be sure to follow us on LinkedIn or subscribe to get notified of our newsletters so that you know about these shows and our deep research coming out. Until next time, thanks everyone.